In the far reaches of the cosmos, in the darkness of interstellar space, from time to time, a flash of light appears, so powerful that for a brief moment, it outshines entire galaxies. These are gamma-ray bursts, the most powerful explosions since the Big Bang. They usually last only a few seconds, sometimes a minute. But what happened on 2 July 2025 had never been seen before. The Fermi telescope recorded a burst that lasted 7 hours. Astronomers named it GRB 250702b.
At first, no one knew what was actually happening. Such a long burst did not fit any known category of phenomena. Typical gamma-ray flashes arise when a massive star ends its life, collapses into a black hole, and ejects streams of plasma into space at nearly the speed of light. But this case was different. A team of scientists from Liverpool John Moores University and other institutions around the world observed this extraordinary event across the entire electromagnetic spectrum, from gamma rays through visible light, all the way to radio waves.
In light of what was observed, a bold hypothesis emerged. Perhaps the black hole not only consumed the star, but actually plunged into its interior and tore it apart from within. That would be an entirely new kind of cosmic catastrophe, one no one had dreamed of before.
Gamma-ray bursts were first discovered in the 1960s, when U.S. military satellites, designed to detect nuclear tests, began recording mysterious pulses from space. Only 3 decades later was it established that their sources are supernovae, exploding massive stars. When they run out of fuel, the core collapses into a black hole, and part of the outer material forms a rotating accretion disk. From this disk, like a giant launcher, magnetic fields shape narrow jets of plasma that race at nearly the speed of light. If one of those jets happens to be aimed at Earth, it momentarily dazzles telescopes with gamma rays.
Yet GRB 250702b behaved quite differently. Its light was pulsing, as if the source beat with a rhythm not previously recorded. Some scientists began to suspect that it might be a star orbiting a black hole, losing part of its material with each pass until it is finally torn apart. Others were skeptical. In their view, if that were the case, the gamma radiation shouldn't exhibit such regular pulses.
Some researchers tried to explain the phenomenon another way. When a star comes too close to a supermassive black hole at a galaxy's center, it is shredded, and the liberated matter shines brightly across the spectrum. But in this case, the source's burst was far from the galactic center. Hence, another possibility arose, that an intermediate mass black hole located in the galaxy's outskirts was involved.
Over time, telescope data began to indicate that something even more unusual might be happening at the heart of this event. Theorists proposed a model in which the black hole not only orbits the star, but penetrates its interior. When the star exhausts its hydrogen fuel, its core becomes a dense helium remnant, and the outer envelope swells. It is then that the black hole is dragged inward, plunges deeper, and begins to devour the star's heart from within. The energy of this process can produce a jet lasting for hours.
As astrophysicist Daniel Perley notes, this phenomenon doesn't resemble any known type of gamma-ray burst. And although several theories have already been put forward, there is no consensus yet. GRB 250702b is slowly fading from the sky, and with it the chance to gather further data. In astronomy, there is a rule that the farther we look into the cosmos, the further back in time we see. But are we sure? For decades, scientists have based their distance estimates to galaxies and gamma-ray bursts on redshift, assuming that the more stretched the light is, the faster the object is receding from us. Yet not everyone agrees. Some researchers point to an old controversial concept, the tired light theory.
According to it, light traveling for billions of years loses energy not because the source is receding, but because it encounters matter, magnetic fields, and dust particles that gently sap its energy and shift its spectrum toward the red.
If that hypothesis contained even a grain of truth, some observations deemed extremely distant might not be so far away. In the context of the latest record-setting gamma-ray burst, GRB 250702b, this debate returns with new force. For if the light from this event was partially tired on its way to us, its energy and distance could have been misestimated. But regardless of whether we're looking at an event billions of light years away or somewhat closer, one thing is indisputable. The power of this burst was unimaginable.
But the story doesn't end there. A team of astronomers led by Elisa Neitz and Eric Burns recorded data from 4 different instruments, including the Interplanetary Network and Japan's MAXI telescope. Their analysis revealed something that exceeded everyone's expectations. GRB 250702b lasted as long as 25,000 seconds, nearly 7 hours, the longest in the history of observations. The radiation was extremely hard, with rapid brightness changes on sub-second timescales and an enormous total energy. Such features can arise from ultra-relativistic jets powered by a rapidly spinning central engine, most likely a stellar mass black hole. Moreover, none of the existing models can fully explain such a phenomenon. The best fit is the so-called helium merger model, in which a black hole plunges into a star stripped of its outer layers and devours it from within, until the explosion tears it apart.
The latest observations with the James Webb Telescope have confirmed that GRB 250702b is the most energetic cosmic explosion ever recorded. They also established that the event occurred in a distant galaxy billions of light years away. Interestingly, no bright supernova was found nearby. Perhaps it is hidden by dense galactic dust that suppresses its light.
Researchers also noted that the host galaxy is exceptionally large and dusty, which is atypical for such events. Gamma-ray bursts usually occur in small, young, star-forming galaxies. This time, the environment looked completely different, which may suggest that it played a key role in creating this cosmic catastrophe.
The energy analysis produced staggering numbers. 3 of the main outbursts of GRB 250702b released on the order of 2 × 10 to the 54 ergs. It's hard to imagine, but that's roughly equivalent to the simultaneous explosion of 2,000 supernovae.
For comparison, the famous Bot burst from 2022 was indeed brighter, but it only lasted about 10 minutes. If you sum the energy of all phases of GRB 250702b, the total budget is comparable, but spread over an entire day.
Astronomers are still analyzing data from the Fermi, Hubble, and Webb telescopes, as well as from Europe's Very Large Telescope. Additional X-ray observations showed that the source was active even a day before the main explosion. Meanwhile, radio data from Australia's ASCAP telescope found no persistent source, indicating that the brightening was a transient phenomenon.
We may never know the full truth about what really happened billions of years ago in that corner of the cosmos whose light has only just reached Earth. But one thing is certain. GRB 250702b is reshaping our understanding of the deaths of stars and the births of black holes, and it reminds us that even in the era of powerful telescopes, the universe can still surprise us.
If that hypothesis contained even a grain of distance. But regardless of whether we're looking at an event billions of light years away or somewhat closer, one thing is